Welcome to Lesson 2 on bond polarity. Our lesson objectives: determine how strongly an atom of an element attracts electrons in a chemical bond, using electronegativity values from Table S, and determine the degree of polarity in a bond based upon the electronegativity difference between the two bonded atoms. So when we look at a covalent bond, again, co means sharing, a sharing of valence electrons, we could have equal sharing or unequal sharing. So we're going to first look at equal sharing of electrons, which we call a non-polar covalent bond. Again, it's equal sharing of electrons. Why? So let's look at the example I have here, which is hydrogen. And so if these are both hydrogen atoms, they both have the same attraction for electrons. Their electronegativity value from Table S is 2.2. And so if they're both equally attracting electrons, then the pull on electrons towards the nucleus is going to be the same. And so if you think of a game of tug of war, nobody wins that game of tug of war. So electrons stay or are shared somewhat equally. And you can see here in this electron density model that the electrons are evenly dispersed throughout both atoms. So this is a sharing of electrons equally. And how do we know that? We're going to look up the electronegativity values, the attraction for electron on Table S for each atom, and then the difference, which we call the END, the electronegativity difference. If it's 0, as in the case of this here, 2.2 minus 2.2 is 0, to 0.4, which is still pretty equal, then we say it's a non-polar covalent bond. And this usually happens between identical atoms, but it can happen in some other cases when the atoms are not the same. For example, between carbon and hydrogen. If they're unequally sharing electrons, we call it a polar covalent bond. So how do we know it's unequal sharing of electrons? What we're going to do is look up the electronegativity values for each atom, and if the difference between the atoms is greater than 0.4, we say it's unequal and we call it a polar covalent bond. So what happens as a result is that one atom is slightly negative and one is slightly positive. Let's see why. So if you look at the game of tug of war here, you can see that if this is the more electronegative atom, it's stronger. It's going to pull the electrons closer to it. It can't quite take the electrons like an ionic bond. It's not strong enough to do that, but it's strong enough to kind of pull the electrons closer. And so if you look at this electron density model here, you'll see that there's a greater density of electrons around this atom than this atom. And since electrons are negative, it builds up a partial charge of negative on this side and positive on this side. So it's setting up a polarized molecule, which we call a dipole. Di meaning two. It has two poles, a positive and a negative. So if we compare the types of bonds that we have, equal sharing of electrons when they have the same or almost the same electronegativity values, that's a non-polar covalent bond. When one of the atoms is stronger than the other, but they're still nonmetals, we get a polar covalent bond where one atom is slightly stronger, and so we develop this partial negative charge here, and then the other side develops a partial positive charge, and this is called that dipole. And then if one atom is so strong it actually takes the electrons from the other, that's when you have a metal and nonmetal, and we call that an ionic bond or ionic compound. And we can see there's a complete transfer of electrons. So it's not just a dipole, we actually have ions, a negative ion and a positive ion. So how do we determine then the type of bond? Well, the first thing you do is you look at the players involved. If it's a metal and a nonmetal, it's simply an ionic bond. There's a complete transfer, as we saw here, of electrons, and that's it. If it's a nonmetal and a nonmetal, it's a covalent bond. Co meaning sharing. So now are they sharing equally or unequally? Well, that's where the electronegativity values come into play. And so if the difference between the electronegativity values between the two atoms is less than or equal to 0.4, so 0 to 0.4, it's nonpolar. If the electronegativity difference between the two atoms is greater than 0.4, it's polar. So let's see an example here. We have the bond between Na and S. So Na is a metal, S is a nonmetal, so metal and nonmetal, it's simply an ionic bond. It's a complete transfer of electrons. Here we have C and Br. Both of those are nonmetals. So nonmetal and nonmetal, that's covalent. Now I want to figure out what type of bond is it. Is it polar or nonpolar? So I'm going to look up the values for C and Br on table S. So here is C, carbon, and the electronegativity value is 2.6. And then for Br is 3.0. So the difference, 3 minus 2.6, is 0.4. And so this falls under the category of nonpolar covalent. It is almost polarized, but not yet. Anything greater than 0.4 makes it a polar bond. Looking at the next example, we have O and F. Oxygen and fluorine are again on the right side of that staircase, so they're nonmetals. So nonmetal and nonmetal covalent. And now we determine, is it polar or nonpolar? So I look up the values of electronegativity for each one. So oxygen is 3.4, and then fluorine is 4.0. So the difference between 4 and 3.4 is 0.6, and that makes this a polar covalent bond. And so the electrons are going to be pulled closer to the fluorine because it has a value of 4. It's higher than oxygen. So it attracts electrons more, and the electrons will be closer to the fluorine side, building up a partial negative charge on the fluorine atom, and then a partial positive charge on the oxygen atom. Okay, let's check our understanding. Can you determine how strongly an atom of an element attracts electrons in a chemical bond using electronegativity values from table S? And can you determine the degree of polarity in a bond based upon the electronegativity difference between those two bonded atoms? At this point, you should be able to determine how strongly an atom of an element attracts electrons in a chemical bond using the electronegativity values from table S, and determine the degree of polarity in a bond based upon the electronegativity difference between the two bonded atoms.